January 19, 2022, 10:31 a.m. Attempt to explain correlation, Pearson correlation coefficient, and p-value. So what is correlation? I'll explain it using some examples because definition is not that much intuitive to me. Suppose we have two data sets, X and Y. These are the two sample data sets from some population, different or same, doesn't matter. It matters though, but not for the sake of explaining. If there is some relationship between these two data sets, then we say that the data is correlated. And what is the meaning of relationship? Suppose if there are some changes in the first data set, that is X, then it will cause some changes in the data set Y. It basically means that there is some linear relationship between the two data sets. Then we call them to be correlated. Now, how much they are correlated, the extent of correlation, the degree of correlation, that is something which we measure using correlation coefficient. There are three of them: Pearson correlation coefficient, Spearman correlation coefficient, and the Kendall-Tau correlation coefficient. And now, what is the value of correlation coefficient and how it tells the degree of correlation? Correlation coefficient, we will talk about the Pearson one, the Pearson correlation coefficient. It ranges from -1 to 1. If the value of R is at extremes 1 and -1, then we say there is a strong correlation or association with the negative value, correlation with the positive value. Although I don't know the meaning of association, there is a high correlation or the perfect correlation at extreme values. And if it's 0, the middle value, then there is no correlation. The data are uncorrelated completely. So now, if we calculate the R value using this Pearson correlation coefficient, there is a proper formula for this. I'll just quickly show the formula. This is the formula for the correlation. For uncorrelated data sets, R is equal to 0. Alright. Now, if we take two data sets, same this X and Y, and we perform this Pearson correlation coefficient calculation, we get some value of R. Alright. So let's say our null hypothesis is that we take these data sets from a Gaussian distribution and they should be completely uncorrelated. There should be no correlation because we take the data at random. So our null hypothesis will be that R is equal to 0, that is the data is totally uncorrelated. Now we calculate using this Pearson correlation coefficient calculations, the R value, and we get some deviation, that is R is not coming out to be 0. There is some deviations, and the deviation can be slight, that is it is something close to 0. The correlation coefficient can be something like this, or it is a bigger value, say 0.2, 0.3, 0.7. It depends upon the data itself. Now, when do we say that it is still correlated or uncorrelated? How can we define that from the R value? Here comes something called p-value. P-value is that reference which tells us that for a value of R which we are getting, is the data still uncorrelated or correlated? So suppose the correlation, that coefficient follows T distribution. I exactly don't know what follows. Yeah, T equals to R root n minus 2 upon 1 minus R square, where n is the number of data points. Let's say there were 100 data points in X and Y. So n is equal to 100. So this n minus 2 becomes 98 upon 1 minus these R square values, and T equals to R times this. This is the T parameter of the T distribution. In the Pearson correlation coefficient, it has to follow this distribution. That is how it is defined probably. So the p value is that suppose we get some t value for this particular r and n value, suppose we get something here. So the p value will be the area of under the both the tails for the same probability, you can say. This is what I got on internet. This is p value. Now for a particular r value, if this p value, that is the probability or the area, if this value is greater than some significance level, that is called alpha, and let's say that significance level for us is 0.05, that is 5%. If this p value is greater than or equal to this 5%, what does this imply is that r value does not deviate much from r equal to 0. That is, the deviation in the r is not that significant. The correlation which these values is showing is not significant, and our null hypothesis still holds good. That is for probability greater than some significance level. But if p drops down to less than 0.05, that is the p value, not the p probability itself, probability will be less than 5%. So if this p value, it drops down to less than 0.05, then this, what does it mean is that r value will deviate significantly. R deviates significantly from r equal to 0. So this basically tells us that there is some correlation in our data set, and it contradicts our null hypothesis that the data is uncorrelated, that is r equal to 0. So it breaks down our null hypothesis. That is something what correlation is, and correlation coefficient, the measure of the correlation, and how we then judge that this correlation coefficient tells us if there is a greater correlation or a small correlation, or there is a significant deviation from r equal to 0. That is something then further defined by the p value. So that was all. Thank you. Signing out.